Here at nTopology, we talk a lot about field-driven design. In this video, I will show you a little bit of what we mean by that. So in this example, we imported a CAD geometry and ran a static analysis. I designated a force. As you can see here, a couple of restraints on these two faces. And then we run a static analysis, and what we're looking at now is a von Mises stress map, seeing the higher stress in red. So what we did here is we have this lattice region, and we're going to apply a gyroid infill to this region. Now within the approximate thickness parameter of this infill gyroid, we have a ramp block, along with a field from point map, and then a von Mises stress point map. And what we're going to do here is drag our static analysis into this von Mises stress point map input, and then what we're going to do is convert that point map to a field. And using that field, we will be able to variably thicken this gyroid. So now I'm going to drag the static analysis I performed into the point map block, and from here convert it to a field, which will be the first input to my ramp block. Now I can start assigning values to my in-min and in-max inputs. In this example, I want my min and max von Mises stress values to be the inputs here. I can manually type in these values, or I could take a different approach. I'm going to use a min block, change it to a real list input, then I'm going to go into the Properties tab of my static analysis and drag in the values variable into my min block input. And now I've quickly located my minimum stress value, and if I were to rerun the analysis and get different results, this connection will never be broken. I then perform the same operation for the input to my in-max. To finish filling out this block, I need values for my out-min and out-max. I made these variables for my min and max gyroid thickness, which I will drag into the corresponding inputs. Essentially what this ramp block is saying is that at the minimum stress value, my thickness will be a value of 1 millimeter, and as I approach my maximum stress value, the thickness of my gyroid will also approach this inputted value of 5 millimeters. Now you can see that we have a gyroid infill in which the thickness is driven by this stress field. We can apply this field-driven approach to many other parameters of our geometry, like variably shelling a part. Here we have a simple bracket in which the setup is very similar to the previous example, but now I'm going to use my stress field to variably shell this part. nTop platform enables you to create a relationship between workflows like simulation and design to help you iterate faster and work more efficiently. Thank you for watching.